An enormous warning has just been broadcast to Earth by the James Webb Space Telescope, and it is approaching. Proxima B, an exoplanet, is the source of this warning. As additional images are returned, more doubts are raised, which worries authorities. With every image taken from this far-off planet, our curiosity about the secrets of the cosmos grows. Concerns over a possible hostile planet close to Earth are becoming more and more pressing. Is there an alien planet nearby that might be hostile? Is Proxima B a threat to our survival as we know it? Although the possibility of alien life has long fascinated humans, we can now investigate it in greater detail than ever before because to advancements in technology like the James Webb Space Telescope. Finding solutions, nevertheless, isn't made simple by the cosmos. In an effort to uncover any signs that could point to extraterrestrial life, we keep searching for signs of life outside our solar system using the greatest instruments available to us, like the James Webb Telescope. But let's face it, every new picture and piece of information only serves to highlight how little we actually know. Although these findings may be revolutionary, they also serve as a reminder of the universe's vastness and complexity, which leaves us with more questions than answers. Comprehending a distant planet such as Proxima B has the potential to reshape our position in the cosmos. Astrophysics specialists find this exciting, but the general public often perceives it as another piece of distant, abstract, and occasionally overpowering space news. Many people worry what this means for life on Earth, as these disclosures seem to raise more questions than they do answers. Is it possible that Proxima B has life, or even intelligent life, that could endanger humans in the future? Even with the James Webb Space Telescope's enormous power, there is only so much it can display. Indeed, some amazing new discoveries have been made, such as the realization that the universe is even larger than previously thought and the availability of breathtaking new photos of Proxima B. What happens next, though? These findings have applications that sometimes seem as far-reaching as the cosmos itself. Many scientists considered Proxima B, which was found in 2013 as a result of its gravitational interaction with its star, to be a significant scientific discovery. Discovering this exoplanet was similar to finding a new neighbor in space. Proxima B is a fascinating candidate for more research because it is only a little bigger than Earth and revolves around its star every 11 days. The prospect of another world so near to ours is thrilling from a scientific standpoint. However, most individuals find it difficult to relate to a location that is 25 light-years away. To put that into perspective, it would take tens of thousands of years for even the fastest spacecraft ever designed by humans to reach that location. Consider what it would be like to stand atop Proxima B. Proxima Centauri. The star would be seen as a large, dim red glow in the sky that is considerably darker and colder than our Sun. A year on Proxima B lasts slightly longer than a week due to its rapid orbit. As a result of its constant rotation around the star, one side of the planet experiences unending daylight, while the other is enveloped in continuous darkness. Although it seems like something from a science fiction book, the truth would be much crueler. Due to the continuous heat exposure on Proxima B's bright side, any water would probably boil into steam, whereas on the dark side, it would solidify into ice. Proxima Centauri, the star of the planet, is likewise not a peaceful and steady neighbor like our Sun. Instead, it emits strong flares and radiation, which makes Proxima B's surface perilous for life as we know it. It doesn't seem like the kind of neighborhood where people would want to live. When scientists discovered an odd signal in late 2020 that originated from the Alpha Centauri system, which contains Proxima Centauri, interest in the search for extraterrestrial life reached a climax. The distinctive frequency of 982.551 MHz of this broadcast attracted everyone's attention. Though it is far too soon to make any firm conclusions, such a signal might, in theory, be a sign of advanced technology. Greater recently, the possibility that Proxima B's atmosphere contains water vapor sparked even greater enthusiasm thanks to the James Webb Space Telescope. Water might change everything since, as we all know, it is an essential component of life. In order to gain a deeper understanding of Proxima B's water content, scientists are using sophisticated methods such as spectroscopy. Using this technique, they can identify the gases that envelop the planet, functioning like an advanced investigative instrument. Scientists can distinguish between particular gases, including carbon dioxide, methane, and oxygen by examining the planet's light spectrum. These gases are all necessary for life. Another important strategy is atmospheric modeling. Scientists can estimate the properties of Proxima B's atmosphere by conducting computer models of it. These models fulfill a similar function to that of dinosaur bones, which paleontologists use to piece together the possible morphology of extinct animals. But the more we understand about Proxima B's environment, the more it serves as a reminder of the astonishing variety of life that exists on Earth. For example, microscopic organisms known as extremophiles can thrive in harsh environments like acidic lakes, boiling hot springs, and the bitter cold of Antarctica. These hardy organisms show that life can adapt to previously unthinkable circumstances and flourish there. Is Proxima B's life similarly flexible? There are several obstacles in the way of Proxima B's search for life, both in terms of space exploration and demonstrating the viability of life in such a harsh environment. Strong space radiation is hurled towards the planet, and its atmosphere may not provide much shielding. Furthermore, in order to make space travel to Proxima B practical, new forms of propulsion systems are required due to the huge distances involved. Future exploration prospects are fascinating when it comes to concepts like solar sails, ion propulsion, and even more fanciful ideas like warp drives. But before these technologies can be applied to actual missions, they still need a great deal of study and development. Even while it's exciting to imagine traveling to space in the future, we must maintain reality. The search for life on Proxima B is hampered by scientific and technological obstacles. We can only hope to realize the full potential of far-off worlds like Proxima B by developing our technology and expanding our knowledge of the cosmos. This endeavor is not just about sating our curiosity. It's about pushing the envelope of human accomplishment. Could humans possibly land on Proxima B, or perhaps communicate with life there in the future? The prospect of discovering aliens no longer looks like science fiction when we think about the arduous trip to Proxima Centauri. Rather, it appears like a genuine, attainable possibility. Innovative groups such as Breakthrough Initiatives have given this thrilling transition from a far-off dream to a scientific undertaking considerable consideration. These organizations are investing vast sums of money to turn what with today's technology could be an impossible goal, one that would take tens of thousands of years, into a mission that can be completed in a few decades. In the scientific community, there is a renewed sense of hope and inventiveness due to the goal of visiting another star system during human lifetimes. But the harsh reality of our current technology limits soon dampen these lofty aspirations. Even while space exploration has come a long way, reaching Proxima Centauri, which is 4.2 light-years away, still poses enormous hurdles. Such a travel is not possible with the current propulsion methods since they are just too slow or inefficient. One of the most prominent initiatives is Breakthrough Starshot, which aims to accelerate small spacecraft to up to 20% the speed of light using strong laser-driven sails. Although there is potential in this concept, it is still at the experimental stage and needs to overcome many logistical and technological challenges, like limiting space debris damage and guaranteeing reliable long-distance communication. The possibility of reaching Proxima Centauri and maybe finding extraterrestrial life is becoming more real than it ever has, yet it is still limited by current technological capabilities. With today's technology, accelerating a spacecraft to virtually the speed of light seems nearly unattainable. It's like attempting to solve a challenging jigsaw in the dark. There are many practical obstacles to overcome, even for audacious initiatives like Starshot, which uses lasers to drive a spaceship toward Alpha Centauri. The lasers are disturbed by the Earth's atmosphere, which makes it challenging for space exploration instruments to operate with the necessary precision. Adaptive optics, which uses miniature lasers on satellites to continuously detect and compensate for atmospheric disturbances, is one recommended remedy. This technology would assist in keeping spacecraft in the line of sight of strong ground-based lasers while they are in orbit. However, the laser propulsion system would only function for a brief period of time and requires a massive quantity of energy, equivalent to the whole energy utilized by the United States. Imagine deploying a massive region with 100 million lasers to accelerate a tiny spaceship that is only 33 feet wide to 20% the speed of light. Even at this speed, it would take the spaceship 22 years, longer than many people's lifetimes, to reach the Alpha Centauri system. However, there are more than only technological challenges to overcome in the quest to reach Alpha Centauri. There are also environmental ones. There are a lot of problems associated with space junk, the sun's gravity, and the sheer size of the distance. It would take approximately 4 years for a signal to get from Earth to Proxima B, so even exchanging messages with a spaceship in transit would be like transmitting messages through time. There is still a growing urge to investigate other star systems in spite of these formidable obstacles. Rather than being motivated by a pragmatic need, it is driven by humanity's innate passion of exploration and discovery. Numerous practical obstacles must be overcome, even for audacious programs like Starshot, which intends to use lasers to launch a spaceship near Alpha Centauri. On the other hand, resolving these issues might transform space exploration. However, due to the possible risks, which include natural disasters and a delay in communication, careful planning is necessary. Many scientists think that the benefits of science greatly exceed the drawbacks, notwithstanding the challenges. The prospect of finding life on Proxima B or any other far-off exoplanet is nevertheless a source of fascination for people all around the world. In human history, finding life on another planet would be the most significant scientific breakthrough. It might shed light on the beginnings and prospects of life on Earth in addition to changing the way we perceive ourselves and our role in the cosmos. Humanity is searching for life in the real world, while simultaneously harboring aspirations of visiting other planets. Finding planets such as Proxima B is only the start. Through the observation of how these planets interact with their stars, either by obstructing part of the starlight as they pass in front of them or by causing the stars to wobble due to their gravitational pull, telescopes such as Kepler have played a crucial role in locating distant worlds that may harbor life. We can get additional information about their dimensions, makeup, and possible habitability. Having finished Kepler's mission, the James Webb Space Telescope is taking over. It can now study planets that were previously too far away or too dim for humans to examine because of its capacity to detect infrared radiation. Our knowledge of the universe and the potential for extraterrestrial life is growing as we discover more about Proxima B and other exoplanets. With the discovery of exoplanets like Proxima B, the James Webb Space Telescope has expanded the search for extraterrestrial life. Although we are still in the early stages of investigating the possibility of life on this far-off planet, our curiosity and technological advancements will continue to push the limits of what we currently know. Whether or not Proxima B is home to life, the search for it has already altered our understanding of the cosmos and ourselves. The hunt for alien life becomes more exciting and urgent as we learn more about the universe's mysteries. We can now see further into space than we could have in the past because of technological developments, especially in the field of observational astronomy. Our understanding of planetary systems is being revolutionized by tools such as the James Webb Space Telescope, which enable us to study the atmospheres of distant worlds and find possible evidence of life. Proxima B's presence in the habitable zone of its star, where conditions could permit the existence of liquid water, is one of its most exciting features. Because it is neither too hot nor too cold, this area is sometimes referred to as the Goldilocks zone, providing a climate that is suitable for life as we know it. Scientists think that Proxima B might support life forms, even if they are very different from earthly ones, if it has the correct atmospheric conditions. Furthermore, research on Proxima B provides insight into the circumstances that might have influenced life on Earth. Through an analysis of Proxima B's geological and atmospheric features, scientists can learn more about the genesis and development of planets in many star systems. Comparative studies of this kind may provide light on the mechanisms leading to habitability and provide hints as to how life could develop in various settings. The study of life in the universe, or astrobiology, is an important aspect of this investigation. In addition to searching for life, scientists in this field are interested in learning how life might adapt to harsh environments. This information may help us look for life in areas that were thought to be uninhabitable, such Titan's methane lakes or the frigid moon Europa. In addition to raising hopes for the discovery of life, Proxima B's enthusiasm highlights humanity's fundamental drive to learn more about and comprehend our place in the universe. Ethical issues are raised when we consider the possibility of intelligent living forms. How would we communicate with extraterrestrial civilizations if we came across them? What rules would we set up to guarantee understanding and respect for one another. The social ramifications of finding life elsewhere are also significant. A revelation of this kind might refute long-held notions and ideologies, forcing a reconsideration of humanity's place in the cosmos. As countries and organizations come together in a shared pursuit of knowledge and exploration, it might spark a new era of cooperation.